The ground beneath humanity's next lunar base may already be moving. For years, every serious plan to return to the moon has relied on one assumption that nobody bothered questioning. The moon was finished, geologically dead, stable enough to anchor habitats, landing pads, fuel depots, and permanent infrastructure, expected to survive for decades without the kind of tectonic threats that constantly reshape Earth. Then, orbital cameras found something that should not exist. Across huge sections of the lunar surface, enormous cliffs stretch for miles through fields of grey dust. Their edges are unnaturally sharp. Their shadows fall black against the regolith. And most disturbing of all, they look new, not ancient. New enough to suggest the moon is still physically changing right now. That single discovery quietly introduced a dangerous possibility. Humanity may be preparing to build permanent settlements on ground that is still cracking apart. For most of modern history, the moon represented stability itself. It had no atmosphere, no weather, no oceans, no plate tectonics. The violent period of bombardment that scarred its surface had ended billions of years ago. Compared to Earth, the moon looked frozen in time. That assumption became deeply embedded in engineering logic. Future lunar habitats under programs like NASA's Artemis program were being designed under the belief that the lunar crust behaved like solid concrete. Once construction began, the ground beneath those structures was expected to remain motionless indefinitely. Then the images from the Lunar Reconnaissance Orbiter mission started forcing a very different interpretation. Its high-resolution cameras began mapping strange formations across the moon's surface. Long cliff-like structures, sharp ridges rising hundreds of feet above surrounding terrain. Jagged scarps cutting directly through impact craters that should have erased them if they were ancient. The images were unmistakable. These fractures had formed recently. And that immediately broke the safe version of the story. Because those cliffs were not impact scars. They were tectonic faults. The moon itself was physically contracting. The cause sounds simple. The consequence is not. Unlike Earth, the moon has no active molten core driving plate tectonics. But deep inside, it still contains ancient residual heat left over from its violent formation billions of years ago. That heat has been escaping slowly into space. And as the interior cools, the entire moon shrinks. Very slightly. Over immense periods of time, scientists estimate the moon has contracted by roughly 150 feet in diameter. That shrinking process creates stress inside the crust. And eventually the crust responds the same way drying mud behaves under pressure. It cracks. Suddenly, those giant scarps cutting across the surface no longer looked like old geological artifacts. They became evidence of an active system, still moving beneath the surface. The moon had not stopped changing. It was simply changing too slowly for anyone to notice. Until now. But that was not the dangerous part. The dangerous part emerged when researchers connected those cliffs to something already known for decades. Moonquakes. Beginning during the Apollo program era, astronauts deployed seismometers across the lunar surface. The instruments detected hundreds of seismic disturbances over several years. At first, these moonquakes were treated as geological leftovers, harmless remnants of ancient cooling processes. But after comparing seismic data with newly discovered thrust faults, the interpretation changed. Some moonquakes were not ancient echoes. They were active tectonic events happening in the present. And suddenly, the original discovery stopped being about strange cliffs. Now, it was about infrastructure failure. Because permanent lunar settlements are fundamentally different from temporary missions, a short landing can tolerate environmental uncertainty. Permanent bases cannot. Habitat modules require rigid seals, pressurized chambers, stable foundations, perfect structural integrity. Even minor shifts in ground position create dangerous stress concentrations. On Earth, engineers compensate using flexible foundations and decades of seismic modeling. The Moon offers neither advantage. No historical database. No long-term tectonic maps. No predictive fault movement models. And the giant, razor-sharp scarps seen from orbit now suggest some future lunar colonies may unknowingly be positioned near zones capable of shifting beneath them. The original image changed meaning again. Those cliffs stretching across silent grey terrain once looked like harmless geological wrinkles. Now, they looked like warnings. And the scale of the problem kept expanding. Many of the safest proposed landing regions focus on the lunar South Pole. This area offers access to permanently shadowed craters containing frozen water deposits, essential for oxygen production, fuel manufacturing, and long-term survival. But high-resolution imaging has found contraction scarps surprisingly close to several regions being studied for future operations. That creates an uncomfortable dependency. The entire architecture of lunar colonization depends on terrain stability. Landing systems assume flat ground. Solar arrays assume structural alignment. Mining systems assume stationary excavation platforms. Habitats assume pressure vessels will remain sealed year after year. But every one of those systems secretly depends on something nobody expected to question. The Moon itself staying still. And now that assumption is weaker than it was yesterday. Return to that original image. A giant black shadow stretching behind a razor-sharp lunar cliff. For decades, it looked like frozen evidence from an ancient, dead world. Now it means something completely different. That shadow may mark a fracture line from a planet-sized object still physically shrinking beneath future human infrastructure. Not millions of years ago. Now. The greatest danger on the Moon may not come from radiation, or meteor impacts, or life support failure. It may come from the ground itself. The Moon never stopped moving. We were standing on the wrong assumption.